Hello student, good morning. Today I am going to discuss orbitals and quantum numbers. This is very important for you people, and many questions are asked only from this topic, orbitals and quantum numbers. Listen carefully. A large number of orbitals are possible in an atom. Quantitatively, these orbitals can be distinguished by their size, shape, and orientation. Three things. These can be distinguished by size first, second shape, third orientation. An orbital of similar size means there is more chances of finding the electron near the nucleus. Correct? Important point. An orbital of a smaller size means there is a more chance of finding the electrons near the nucleus. Similarly, shape and orientation means that there is a more probability of finding the electron along certain direction. Orientation means it is related to direction. Atomic orbitals are precisely distinguished by what are known as quantum number. Already I told you, all quantum numbers is just like an address to find out the orbital in which electrons resides. Correct? Or you can tell quantum number is an address to find the electron in three-dimensional space in an atom. Each orbital is described by three quantum numbers. Each orbital is designated by three quantum numbers as small n, L, and m. Three notations are there: n, L, and m. Three quantum number. Fourth quantum number we will discuss in the last. Then n, L, and m. Now I am going to tell you, be careful in understanding all the things. Listen carefully because it's full of concept and many questions are asked from this concept. Then first you understand what is the principal quantum number. Then principal quantum number, it is denoted by n. A small n is a positive integer with value of n. N may be 1, n may be 2, n may be 3. Means n is equal to maybe 1, maybe 2, maybe 3. That is also you can tell cell number 1, cell number 2, cell number 3, cell number 4, or orbit number 1, orbit number 2, orbit number 3, orbit number 4. Already told you that it is called by three names. That is the cell, orbit, and energy level. All have same meaning. The principal quantum number determine the size. See here very carefully. The principal quantum number determine the first size. Second, you can say energy of the orbital. Don't forget. These two things is determined by principal quantum number n. Small n first, size, and second energy. Okay, size when means suppose n is equal to 1, then size will be a small. If n is equal to 2, then little bigger. N is equal to 3, again more, again 4, again bigger. Like that way, you can say if n is equal to 1 means a smaller size, very small, smallest also you can tell. N is equal to 2, little bigger. Again 3, again further bigger. Like that way. Then the principal quantum number determines two things. First, size, and the second, energy of the orbital. For hydrogen atom and hydrogen-like atom, as for example, helium, He+, lithium 2+, etc., energy and size of the orbitals depends only on n, a small n, only n value. But already I told you, but for multi-electrons, it depends upon n and l both. N and L both. This you keep in mind, because this question N and L, that is difficult question, will be asked. N is easy. All knows. All knows about the N. But that is only for one electron. Only for one electron. You can say energy can be determined. Only N is responsible for only one electron atom, like hydrogen, He1+, lithium 2+. Only for this N, only N is responsible. But if electrons are more than one, multi-electron, then that time N and L both are responsible. Okay, here I am telling you, that is a question which can be asked in your competitive examination, maybe medical or IIT. This question may be asked. Now, again you know further about the principal quantum number. Principal quantum number also identifies the cell. That is, if you are knowing principal quantum number, then it may be 1, 2, 3, 4. Then if 3, then okay, you can understand n is equal to 3. If 2 means n is equal to 2. If 1, n is equal to 1. If 4 means n is equal to 4. Then principal quantum number also identifies the cell with the increase in the value. Again one thing, with the increase in the value of n, the number of allowed orbital increases and are given by n square. Its formula is direct. In any orbit, in any cell, how many orbitals are there, directly you can calculate. Formula is there, n square, a small n, n square. If suppose only n is equal to 1, then how many orbitals will be there? Then n square means 1 power square, 2 means only 1. If n is equal to 2, then total number of orbitals will be 2 power 2, that is the 4. If orbit number is 3, then total number of orbitals will be 3 power 2, that is the 9. If 4, then 4 power 2, 16. Here, I want to brief you in a shortcut way. Try to understand. See, within any orbit, so many orbits are there, so many cells are there. Then within the orbit is made from the subcell, and subcell is made from orbitals. These three things you keep in mind. You will get confused. If n is equal to 1 means subcell which is under the cell, that is called subcell, or you can tell cell is made from or consists of subcell, and subcell is consist of orbitals. Okay, means under the subcell orbitals will be there, or under the cell subcell will be there, means cell subcell orbitals. This you keep in mind, that cell is made from subshell, and subshell is made from orbitals. Correct? Hence, total number of orbitals in any orbit, in any cell, that is equal to a small n square. Number of this n is equal to principal quantum number. Already I have given example. N is equal to 1, then 1 square is that means 1 orbital. If n is equal to 2, then 2 square, 4 orbitals. If n is equal to 3, then 3 square means 9 orbitals. Directly you can know the number of orbitals. Then this is very, very important formula I told you, and question is asked, directly you can solve without doing anything. Now again you can tell n is equal to 1, n may be 2, n may be 3, n may be 4. That is also told like that. 1 means k, 2 means l, 3 means m, 4 means n. This is the notation of the cell. K cell, L cell, M cell, N cell. Then first cell is known as K, second cell is known as L, third cell is known as M, fourth cell is known as N, like that way. Size of an orbital, already I told you, size of an orbital increases with increase of principal quantum number n. In other words, the electron will be located away from the nucleus. As the size will increase, electron will be far. Since energy is required in shifting away the negatively charged electron from the positively charged nucleus. From the far means what? It is going away from the nucleus. The energy of the orbital will increase with increase of n. With increase of orbit number, energy will increase. This you keep in mind. Now, I am talking about the second quantum number. Second quantum number, that is called azimuthal quantum number. That is denoted by a small l. A small l. Then azimuthal quantum number, a small l, is also known as orbital angular momentum or subsidiary quantum number. There are two names for the azimuthal quantum number. AZI, azimuthal, AMUTHAR, azimuthal quantum number. L is also known as orbital angular quantum number or subsidiary quantum number. It is denoted by small l. Now, what does it mean, azimuthal quantum number? L. I have told you, this tells about the subshell. Azimuthal quantum number is L. It tells about the subshell. Subshell. It defines the three-dimensional shape of the orbital. What it will tell? It tells about the shape. Keep in mind, question is asked. L means it defines the shape. Size is different. N will tell about the size, whether it is a small size or big size. Size is different. Here it is a shape. Then L means azimuthal number defines the or tells about the shape of the orbitals in three-dimensional space in atom. In atom, for a given value of n, again I am telling you, for a given value of n, suppose n you are knowing, then L you can know. How? Then it will start from the 0, 1, 2, 3, 4, like that way. That's why end will be n minus 1. N minus 1 means it can have value 0 from 0 to n minus 1. Then I told you 0 to n minus 1 value, that is for a given value of n, the possible value of L are 0, 1, 2, like n minus 1. For example, when n is equal to 1, then value of L is only 0. Correct? Yeah, keep in mind. If n is equal to 1, then L is equal to what? 0. For n is equal to 2, the possible value of L can be 0 and 1. For n is equal to 3, the possible value of L can be 0, 1 and 2. Like that way. Keep in mind, whatever number is there, n is equal to 1, means L will have only one value. If n is equal to 2, then L will have 2 values. N is equal to 3, then it will have 3 values. Then 1 values means it starts with 0, then 0. And if n is equal to 2, it will have 2 values. What are the 2? 0 and 1. If 3 values means 0, 1 and 2, means you have to count from the 0 only. And here again I want to tell you very, very important things full of concept. 0 indicates S subcell. 0 indicates S subcell. 1 indicates P subcell. 2 indicates D subcell. And 3 indicates F subcell. Okay. Actually, what is the notation of subcell? Notation of subcell. Then subcell you can tell like S. S subcell, P subcell, D subcell, F subcell. And in each subcell, orbital will be there. Already I told you, in each subcell, orbital will be there. Then these orbitals may be of different type. Then in one subcell, suppose its value is 0, that is the S. 0, that is the S. Then it is called, actually name is subcell, same name. Subcell and orbital will have same name. S subcell, S orbital. P subcell, P orbitals. D subcell, D orbitals. F subcell, F orbitals. Then under the cell orbitals are there. Then first orbit means n is equal to 1. Then here only one subcell will be there, that is a 0 subcell. S subcell 0, 0 value means S. In one you can say when in n is equal to 1, then subcell is equal to also 1, and in that only one orbital will be there, that is the 0, that is called S. Like that way, if n is equal to 2, then you are talking about the second can say subcell. Then second subcell is value is 1. Okay, that is called P subcell. If n is equal to 3, then it will have 3 values, 0, 1, 2. First one was only 0, second one 0 and 1 both, and third one 3. N is equal to 3 means 3 subcell and 3 orbitals. 3 subcell, n is equal to 3 means 3 subcell. And under this 3 subcell means here 0 S will be there, P will be there, D will be there. Like that way n is equal to 4. Then 4 subcell will be there. S subcell, P subcell, D subcell and F, S, P, D, F. very clearly. N is equal to 1, then only one subcell. Which subcell? Then 0 means S, only S orbital will be there. S subcells means S orbital. If N is equal to 2, then 0 and 1 means S and P. And N is equal to 3, then 0, 1, 2, 3 subcell. And like that way, N is equal to 4, then 0, 1, 2, 3, 1 less because 0 you are counting. Then like that way, these I told you about the N and subcell. N and L. Subcell is telling about the L, that is azimuthal quantum number. L means when N you are knowing, then L you are knowing. How both are related? Then very simple formula is there. Keep in mind. That is this N is equal to 2L plus 1. This formula don't forget. This is the second formula I am telling you. Directly I told you, if you are knowing N, the directly total number of orbital you can know, N square. Second formula I am telling you, N is equal to this. If N you are knowing, then how many this will be there, orbitals? Then here N and L both are related. Then this, if 2L plus 1, this is the formula. Means how many subcell will be there? How many subcell will be there? Then 2L plus 1. 2L plus 1. L is the this azimuthal quantum number. Now this I am telling you again. I am telling you. Listen carefully. This formula you keep in mind. 2L plus 1. This formula you keep in mind. That is a relation between N and L. Then suppose L is equal to 2L plus 1 formula is there. 2L plus 1. Then if L is equal to 1, first start with L is equal to 0. Then 2 into 0 plus 1. 2 into 0, 0, only 1. Then this you can know the only one subcell, or in one subcell only one orbital. That is also related. Number of orbital will tell about the number of orbital, will tell about the number of subcell. Number of subcell will tell about the number of orbital. Okay. Then if L is equal to 1, then 2 into 1 plus 1, that is the 3. 3. Then what are the 3 subcells are in this L is equal to 1? Then 3 orbitals are there. What are the 3 orbitals? Then S orbital, P orbital, and this SPD. SPD. Okay. Again I will come. Just now listen. Each cell consists of one, or each cell means N I am talking about. Each cell consists of one or more subcells or sublevels. The number of subcells in a principal cell is equal to the value of N. Both are same number. For example, in the first cell N is equal to 1. There is only one subcell. N is equal to 1. Then L is equal to also 1. Same. For example, in the first cell N is equal to 1. Then there is only one subcell which corresponds to L is equal to 0. L is equal to 0. I told you 0, 1, 2, 3, 4. Then if N is equal to 1, there is only one subcell which corresponds to L is equal to 0. there are two subcell. There are two subcell L is equal to 0, 1 in the second cell. When n is equal to 2, then two subcell. What are that two subcells? 0 and 1. Then 0 is called S, 1 is called P. Keep in mind all the important things are there. Then if n is equal to 2, then their subcell is also 2, 0 and 1. And like that way, L is equal to 0, 1, 2 in third cell. In third cell, when n is equal to 3, third cell will be it. N is equal to 3 means third, n is equal to 4 means 4 subcell, n is equal to 5 means 5 subcell. Like that way, you can understand, and this is a correct also. Okay, each subcell is assigned an azimuthal quantum number. Each subcell means we are talking about the L. Each subcell is assigned an azimuthal quantum number, that is called L. Subcells corresponding to different value of L. Subcell corresponding to different values of L. As for examples, values of L. Suppose value of L is 0, 1, 2, 3, 4, 5. If L value is 0, 1, maybe 0, maybe 1, maybe 2, maybe 3, maybe 4, maybe 5, then 0 means S orbital, 1 means P, subcell. Okay, subcell and orbitals, same you can say notation. Same notation. Okay, because subcell is made from the orbitals. Hence, S subcell, S orbital. P subcell, P orbitals. D subcell, D orbitals. F subcell, F orbitals. Don't confuse. Same designation. Then I am telling you, if L is equal to 0, means S subcell. You are talking about S subcell. If 1, P subcell. 2 means D subcell. 3 means F subcell. 4 means G subcell. 5 means H subcell. Like that way. Then now I told you one subcell. One subcell means only S under the one subcell, only one orbital will be there. Now I am talking about the orbital. Under the one subcell, first subcell, that is talking about the 0. Then there in that subcell orbitals are there, but only one orbital. Which orbital? 0. 0 means S orbital. If subcell is P, then two orbitals will be there. Two orbitals, that is the 0 and 1 means S and P orbitals. Under the subcell 2, if subcell is 2, then 2 orbitals, S and P. If 3, then 3 orbitals, S, P, D. If 4, means 4 orbitals, S, P, D, F. Like that way. Then now we understood that within the orbit, suborbit will be there, means subcell will be there, and within the subcell, orbitals will be there. Means you can tell that in a bigger sense that N means orbit is made from directly from the orbitals. You can tell direct link is there. Then now I told you that 2 azimuthal quantum number I told you. Now come to the these things. Magnetic orbital quantum number M. Magnetic quantum number M. Then here M, magnetic quantum number, what it tells? Then magnetic quantum number gives information about the spatial orientation. I told you magnetic magnetic orbital quantum number m, small m, gives information about the spatial orientation of the orbitals. It will tell about the direction where orbital is there, and you know that in orbital electrons are there. Then first you will search the home, and then you will come in that home where electron is there. That's why importance has been given to orbital, and the end in orbital where electrons are there. Then here this M will tell about the spatial orientation of the orbitals with respect to the standard set of coordinates axis, in which direction it is there, x direction, y direction, z direction, means x axis, y axis, z axis, where it will tell about the orientation. For any subcell, again I am telling you one more relation, what I told you na, 2L plus 1 relation. Here also same relation is there. For any subcell, that is denoted by L value, there will be 2L plus 1 values of M, means M is equal to 2L plus 1. See here, again I am telling you, if you are knowing the value of N, then you can know the value of L. N is equal to 1 means only one subcell will be there, that is the zero subcell, that is also called S subcell. 0 means S subcell. Then you can write 1s. 1 means orbit number, and in that n is equal to 1, then only 0, its value is 0, and 0 means S. Hence subcell notation will be 1s. If n is equal to 2, then n is equal to 2, orbit number 2, then there will be two values of L, 0 and 1. Then its notation is 2s, because n is equal to 2, that's why 2 you are writing. When n is equal to 1 was there, you have written 1s, because only one subcell was there, that is the S, 1s. Now n is equal to 2, then two subcells are there, 2s and 2p, 0 and 1. Then 0, for the 0 you will notation is S, and for 1 notation is P, and both belong to n is equal to 2. Then when n is equal to 2, then 2s and 2p subcell will be there. S and P, both subcell will be n is equal to 2, then 2 subcell, I told you. All are the same, which means n, whatever number of n is there, that is the subcell number, and that number is orbital also. All three same. Then 2, n is equal to 2, then 2 subcell. What are the 2 subcell? Values 0 and 1. Then for 0 means S, then 2S, and 1 means P, then 2P. Means when n is equal to 2, then 2S and 2P subcell will be there. Like that way, if n is equal to 3, then 3 values are there, 0, 1, 2. Then 3S, 3P, 3D. Like that way, if it is n is equal to 4, then 4 values are there, 0, 1, 2, 3. Then 4S, 4P, 4D, 4F, like that way. Then these are the relation between N and L. N and L. Okay, don't confuse. And when you are knowing the L value, I have told you that how N and L are related. Again, I am repeating you because it is very, very important. If n is equal to 1, then only one subcell. I told you number of orbit and number of subcell both are equal, and orbitals numbers are also same, okay, in that particular orbit. Then if n is equal to 1, then L is equal to 0, and 0 means 1s. If n is equal to 2, then 2 values may be there, 0 and 1. Then 0 means S, means 2S, 2P. Like that way, if n is equal to 3, then 3 values 0, 1, 2. Then 3S, 3P, 3D. If 4, n is equal to 4, then 4 orbitals. 4 suborbit may be there. 0, 1, 2, 3. 0, 1, 2, 3. If n is equal to 4, total 4. Then 0 means 4S. 1 means 4P. And 2 means 4D. 3 means 4F. Correct? 0, 1, 2, 3, 4. 4 values are there. For 0, actually 1 less. Keep in mind, because 0 you are using. That's why finally it will be 1 less. In the place of 4, only 3. Because 0 you are using. Then 0 means again S means 4S. 4 you are writing because n is equal to 4. That's why 4 you are writing. Because you are talking about suborbit of the 4th orbit, suborbit of 4. That's why 4 you are writing. So, and this 3 you are using because orbit number is 3. Hence, under the 3, all are coming. 3S, 3P, 3D. And like that way, 2 you are using because under the 2, there are 2S and 2P. And 1 means under the 1, only 1 is there, 1S. Then that's why for n is equal to 1, 1S. For n is equal to 2, 2 are there, 0, 1 means 2S, 2P. And n is equal to 3 means 3 values are there, 0, 1, 2 means 3S, 3P, 3D. Like that way, n is equal to 4, then 0, 1, 2, 3. 0, 1, 2, 3 means 4S, 4S, 4B, 4D, 4F. Then this I told you, relation between n and L. If n you are knowing, then L value you will know. And when L value you are knowing, then now relation is there. That is the m is equal to 2L plus 1. 2L plus 1. Okay. Then 2L plus 1. Now suppose that is the 0. L is equal to 0. Then how many m will be there? Then 2L plus 1. L is equal to 0. Then 2 into 0 plus 1. That is the only 1. 2 into 0 plus 1. That is the only 1. Then thus for L is equal to 0, the only permitted value of m is equal to only 1, 0. 0. Then only one orbital is possible. Then only one orbital, first orbital is S. Only one orbital will be there. That is the S. Means if L value is 0, then m value will be, if L is 0, m value will be 0. Then m value 0 means this thing, for L is equal to 0, the m is equal to is only 1 you are getting. 2L plus 1, L is equal to 0, then only 1. One orbital will be there. That one orbital will be, first orbital is S orbital. Okay. Now same way, if L is equal to 1, L is equal to 1, then formula use 2L plus 1, L is equal to 1, then 2 into 1 plus 1, that is the 3. 2 into 1 plus 1, then 2 plus 1, 3. Then m will have 3 value. Then here you should understand, m value start from negative to positive via 0. Negative to positive via 0. Then here 3 values you are getting. And if L is equal to 1, m is equal to 3 values. Then minus, how will you write? Then minus 1, 0 plus 1. It is written like that. M value will be, 3 values are there. Then minus 1, 0 plus 1. These are the 3 values. Then when L is equal to 1, you will get 3 values. M is equal to 3. Then this 3 values you will get. And I told you what are the 3 values. Then minus 1, 0 and plus 1. Like that way, if m is equal to 2, then if L is equal to 2, then m is equal to 2L plus 1, that is the 2 into 2 plus 1, that is the 5. Then 5 values you are getting, m is equal to total 5 values. What are that? Then you start with this minus 2, minus 1, 0, plus 1, plus 2. That is the total 5. This total 5 values we got. Minus 2, minus 1, 0, plus 1, plus 2. These are the 5 values. If m is equal to 2, L is equal to 2, you are getting 5 values of m. Like that way, if L is equal to 3, then you will get 3 into 2 plus 1, 7 values. Then you can write like this. You start with minus 3, minus 2, minus 1, then 0, then plus 1, plus 2, plus 3. Total 7. M is equal to 3 means, L is equal to 3 means m value is 7 values. Then actually, what are these values? What does it means? These values, when L is equal to 0, then you got only one value, that is equal to S. This is the telling about the orbitals, S orbital. Now, if L is equal to 1, then you got 2L plus 1, means 3 values you got. Then what are, when L is equal to 1, means you are talking about the P, talking about the P orbitals, P subcells. You are talking about the P subcell. First you talked when L was 0, then L was 0, that time you got only one value, that is the 0. Only one value, 2L plus 1, only one value you got. 2L plus 1, L is equal to 0, then only one value you got, that was the S. That S is called actually orbital. That S under the suborbit, I told you orbitals are there. Then how many its number? Then only one number, that is the S. Now L is equal to 1, then m is equal to 3 value you got. Then these 3 value minus 1, 0, plus 1. Then what are these minus 1, 0, plus 1? Then these are the 3 P or because L is equal to 1 means you are talking about the P subcell. L is equal to 1 means 3, you are talking about the P subcell. Keep in mind, L is equal to 0 means you are talking about the S subcell, and L is equal to 1 means P subcell, and these under this P subcell, now you got m is equal to 3 values. Then these 3 values minus 1, 0, plus 1, that is talking about 3 P's. P has types of P's. 3 P's, Px, Py, Pz. Now P orbitals, there are 3 P orbitals, Px, Py, Pz in 3 directions, at x direction, y direction, z direction. That's why this minus 1, 0, plus 1 is telling about Px, Py, Pz orbitals. Under the P, 3 types are there of P. Of P, 3 types, Px, Py, Pz, 3 orbitals. Px orbital, Py orbital, Pz orbitals. Like that way, if L is equal to 2, then 2 into 2 plus 1, 5. Then 5, how will you write? You will start with 2 only. Minus 2, minus 1, 0, plus 1, plus 2, total 5. Then P is equal to 2 means you are talking about the D or D subcell. And under the D subcell, these 5 orbitals are there. 5 different types. D has 5 different type of D orbitals. 5 d orbitals. What we are telling? 5d. Then under the this d subcell 5 orbitals are there, 5 d orbitals. What are that? Then dxy, dyz, dxy, dyz, dzx, dx square minus y square, and last is dz square. Then dxy, dyz, dzx, dx square minus y square, dz square. These are the different types of d orbitals. Under the d subcell, these 5d orbitals are there. dxy, dyz, dzx, dx square minus y square, dz square. These 5 different. D has 5 sun, you can tell like that. D has P has 3 sun, like that you can tell. That's why you are telling them PXY, this for the PX, PY, PZ, 3. For like that way, for D, 5 are there. 5 are there, dxy, dyz, dzx, dx square minus y square, and dz square. These are the 5. Like that way, if you will, it is a 3. If L is equal to 3, then put the value in formula 2L plus 1, then 2 into 3 plus 1, 7. Then F has 7 sun, or you can tell 7 different, F has 7 F orbitals, 7 F orbitals. Then these are complicated. Their name is very complicated, but 7 orbitals are there. Here only you understand that in each orbital, already I told you, in each orbital, maximum 2 electrons can be accommodated, not more than 2, each orbital. Then in S orbital, only 2 electrons is possible. And in P orbital, 3 orbitals. Under the P subcell, 3 orbitals are there, Px, Py, Pz. Then 2 into 3, maximum 6 electrons can be accommodated in P orbital. In P subcell, maximum 6 electrons. In P subcell, maximum, because under the P, 3 types of P are there, Px, Py, Pz. Then 2 plus 2 plus 2, or 2 into 3, 6. Like that way, under the D subcell, 5 different d orbitals are there. Then 2 into 5, 10 electrons can be there maximum in D subcell, maximum 10 electrons. Okay, because under the D subcell, 5 orbitals are there. Like that way, under F subcell, 7 different type of orbitals are there. The 7 into 2, 14, maximum 14 electrons can be accommodated. Then again I am telling you, for S, only 2 electron. For P, 6 electron. For S orbital, a subcell, in S subcell, only 1 orbital is there. Then only 2 electron. P subcell means 3 orbitals are there. Then 6 electron. In D subcell, 5 orbitals are there. 5 orbitals are there, means 10 electron. D subcell means S, P, D. D I told 5, means 10 electrons. Like that way, F means 7 orbitals are there. Then 7 into 2, 14 electrons. This concept is very, very important, and it will help you in calculation also. Okay. Now all things I have told you. Now I am going these things for S, spin quantum number. Spin quantum number I am going to discuss. Then how all are related, I have told you. When N you are knowing, L you can know. Correct? Numbers are same. What is the number of N is equal to 1? then subcell is also only 1, and orbital is also only 1. If n is equal to 2, then subcell is also 2, and orbital is also 2. If n is equal to 3, then subcell is also 3, and this orbital is also 3. If n is equal to 4, then subcell is also 4, and orbital is also 4. Correct? That already I told you, don't confuse. Very easy. After the practice, you can understand better. Then already I discussed in details. Now spin quantum number. Spin quantum number means now when you are talked about the L, this M value, then now you have reached to the different orbitals. Then now in orbital electrons are there. Then now just you know about the spin quantum number S, electron spin S. The 3 quantum numbers labeling an atomic orbital can be used equally well to define the energy, shape and orientation. Correct? First 3. First, principal number tells about energy, azimuthal number tells about the shape, and this magnetic quantum number will tell about the orientation. But all these quantum numbers are not enough to explain the line spectra in the case of multi-electron atoms. In multi-electron, many line spectrums are found, and that's why Bohr was not able to explain. But now here explanation there. Then in multi-electron atoms, many spectra are found very closely, they are attached. Then here some of the lines actually occur in doublet, means two lines. When they are very close, it is called doublet, closely spaced. 2 lines very closely spaced, that is called doublet. Like that way, triplet, 3 lines closely spaced. This is very difficult to, by these 3 quantum number you can't explain. That's why 4th quantum number has come, that explains all the things. Then 4th quantum number is spin quantum number. This suggests the presence of a few more energy levels that predicted by 3 quantum numbers. 3 quantum number is different, 4th quantum number is different. This suggests 4th spin quantum number. This because the doublet and triplets are found. Then how will you explain? Then this suggests the presence of a few more energy level. Then here what happened, that in 1925 George Uhlenbeck, scientist name, another name is Samuel Goudsmit, proposed the presence of the 4th quantum number known as electron spin quantum number S. Sometimes MS is also written, but generally S, small s. An electron spins around its own axis, much in a similar way as a Earth spins around its own axis while revolving around the sun. In other words, an electron has, beside charge and mass, intrinsic spin angular quantum number. Okay, electron has a charge and mass, and third things what is have, intrinsic spin angular quantum number. Spin angular quantum number, spin angular quantum number, that is, you can tell a spin angular momentum of the electron. This is a spin angular momentum. This is a vector quantity. This can have two orientation it has relative to the chosen axis. These two orientation are distinguished by the spin quantum numbers, which can take the value of plus half or minus half. Already I told. This spin quantum number has two types, plus half, minus half. These are called the two spin states of the electron and are normally represented by two arrows. Upside one arrow and downside one arrow. Upside arrow means spin up and downside arrow means it is called spin down. Spin up, spin down. Spin up means plus half is spin up, minus half means down, spin down. Two electrons that have different spin values, S value is different, one plus half and other minus half, are said to have opposite spins. Means because one is plus half, other is minus half, means one is clockwise, other is anti-clockwise movement. Then both are opposite spin. An orbital cannot hold more than two electrons. Already I told you. Any orbital, only any single orbital can't have more than two electrons due to this two reasons, plus half and minus half. Then now I have told you that an orbital cannot hold more than two electrons and these two electrons should have opposite sign. Then I have told all the four quantum numbers. Now again here important things. When you have reached to you are knowing the orbital, then in the S orbital, in S subcell, only S orbital is there. In P subcell, three orbitals are there. In D, 5 orbitals are there. In F, 7 orbitals are there. Then now in each orbital, as for example, if S orbital is there, in S orbital, now only 2 electrons are possible. Then one electron will have a spin quantum number value plus half and other electron will have value minus half because only 2 electrons are there in S. Then one electron will have actually spin. What a spin? Then if it is each electron you can tell, each electron have either it can move plus clockwise or anti-clockwise. Hence possibility is for two values for each electron. Each electron can spin either clockwise or anti-clockwise. Hence each electron will have plus two possibilities, plus half and minus half. Then now you can understand for one orbital, in one orbital 2 electrons are there and each electron can move either clockwise or anti-clockwise. Then it will have two values of each electron will have two spin, plus half and minus half. Then now you can understand just in P 3 orbitals are there. Then in 3 orbitals that now 6 electrons are there. Then for each electron 2 possibilities are there, 2 spin quantum number. Then you can understand that how many spin will be there under P. 6 are there, na? 6 into 2, 12, 6, 3 are there, 3 orbitals are there, Px, Py, Pz, and 6 electrons. 6 electrons are there, means there 12 spin will be there for each electron 2. Then 6 electrons are there, then 12 possibilities are there. Like that way, D5 means 5 orbitals are there. 5 means 10 electrons are there. 5 orbitals means 10 electrons. Then 10 into 2, 20 total 20 possibilities will be there for a spin. For each electron, 2 possibilities. Like that for 7 orbitals for F, 7 orbitals are there. Then 7 means 14 electron. Then for each electron 2 possibilities. then 14 into 2, total 28. Then this you keep in mind. If you want to know the spin, then step by step you have to reach the spin, because it will become very complicated, very complicated. From the n you can get the L value, from the L you can get the M value, from the after that 3 are related. After the fourth one, for each electron 2 possibilities. This you keep in mind. For each electron 2 possibilities, plus half, minus half. Then see how many electrons are there, starting from S to S orbital, P orbital, D orbital, F orbital. How many electrons are there? Then how many S value will be there? You can understand. You only can imagine. Writing is very difficult. Okay. Now I am stopping only here. Next class I will discuss shapes of atomic orbitals. Thank you.